Okay, so 4.3, we're talking about the value of a vehicle. Every year after a new car is purchased, it loses 1/3 of its value. Let's say that a new car costs $18,000. Now, this is unfortunately a very real thing. It's actually an idea called depreciation. And that's the idea that as soon as you buy something and then use it, it's no longer brand new. So people won't be willing to pay as much for it because it's used. So the value consistently goes down the more you use something like a car. So in this case, it's losing 1/3 of its value each year. So part one says, a buyer worries that the car will be worth nothing in 3 years. Do you agree? Well, let's see. If it's losing 1/3 of its value every year, it's always going to be worth something, right? Because even if you take away 1/3 and then 1/3 of that and then 1/3 of that the next year and 1/3 of that, it's still going to be worth something. I think what happened here is might be what the person thought. So here's year one, year two, and year three. So the car starts off at $18,000 and it loses 1/3 of its value. So if we times 18,000 by 1/3, it means it's losing $6,000. So then in year two, it's only worth $12,000. But then what if we subtracted another $6,000? Now it would only be worth $6,000. And now if we subtracted another $6,000, look at that. Now the car is worth nothing. However, the issue with that is we said it's losing 1/3 of its value each year. The $6,000, this guys, that is only 1/3 of the original or the starting value. Each year, we need to take, instead of taking away 6,000, we need to take 1/3 of its current value. And same thing here, we take away 1/3 of its current value. So that's kind of where the difference is. You're not taking away 1/3 of the original each time. You're losing 1/3 of its current value each year. So I'd say we disagree. Don't worry, your car's not going to be worth nothing. Don't worry. All right, so now we're going to write an expression to really show that, to really illustrate that point. Okay, so year zero, right off the lot, it's $18,000. So year one, it's going to lose 1/3 of its value. So if it loses 1/3, it will be worth 2/3. Because remember what we did in the previous example. If you lose a quarter, it's worth 3/4 of that. If you lose 1/3, it's 2/3 is what's left. So this is going to be 18,000 times 2/3 of its value. Okay, then in year two, it's going to be 18,000. It's going to be whatever the value was in year one, but then it's going to only be 2/3 as valuable. Then in year three, it's going to be whatever it was in year two, and then it's going to lose another 1/3 of its value, which means it will be only 2/3 as much. So as you can see, look here, guys. We don't usually rewrite multiplication repeatedly. We can say, well, 2/3 times itself 3 times, we can use an exponent. So the value of the car is really 18,000 times 2/3 times 2/3 times another 2/3 because it's the third year. So now what if we say, well, what happens in the sixth year? Well, it'll probably be 2/3 of the value times year one, year two, year three, year four, year five, and now year six. So it'll be to the sixth power because we have to keep multiplying repeatedly by 2/3 every single time because each year it's losing 1/3 of its value, which means what's left is 2/3 of the value. So any year, right? If you go any year, you're going to start with 18,000 times 2/3 to the t power, however many years that repeats. And sure enough, in number three, it's asking us to write that. So the value V, the value of the car, is 18,000 times what's left, which is 2/3, repeated for however many years. So that's how we write an exponential function. Now, question 4 here. So I'm going to bring this down here. 4 says use your equation to find the value when t is 0. Okay, so the value, 18,000 times 2/3, and use t is 0. Well, if you plug this in your calculator, remember, PEMDAS, exponents has to come first. 2/3 to the 0 power is actually just 1. So this becomes 18,000 times 1, which is just 18,000. And if you look at the table, sure enough, we knew that in year 0, the value was 18,000. So that checks out. Now, the last part here is number 5. It says a different car loses value at a different rate. The value of this different car in dollars after t years can be represented by this equation. D equals 10,000 times 4/5 t. And it says explain what the numbers mean in this situation. Well, let's look back to what we described in our table here. Where did the 18,000 come from? Well, it looked like this was the original or the starting value of the car. And where did the 2/3 come from? Well, that turns out to be what's left, because if you lose a third of the value, what's left after it will be 2/3. So in this case, with this different situation, 10,000 must be what the original or starting value of the car, and 4/5 in this case is what's left, which means that the car was losing 1/5 of its value each year. Because if 4/5 is what's left over, then that means it must have been losing 1/5. So this is pretty good. This is a really good problem that helps us see if you keep repeating and losing a third and losing a third and losing a third, that means every time you're timesing your value by 2/3 and 2/3 and 2/3 for every year that you keep going. And we have a starting value and whatever's left over however many years as you keep going.